You are now watching the Unit 1 Writing Equivalent Equations notes video. So last lesson you watched or more or less reviewed how to solve an equation. So today in this lesson I'm going to kind of just start out by saying a lot of times students get really anxious when they solve equations like this. They freak out. They're like, oh my gosh, there's so many letters. I have no idea what to do. And they go into a state of panic. And I'm here to tell you that you shouldn't be panicking, because I could probably ask that same student, how do you feel about solving equations? And most of the time they say, oh, I feel pretty good. You know, I make mistakes sometimes, but I like solving equations. They're one of the topics that I think I'm good at. So if you're good at solving equations, you are actually really good at writing equivalent equations. You just don't know it yet. Or maybe you do. Maybe you've seen stuff like this before. But most of us, I think, this is going to be a new topic for us. So we're going to just dive into exercise number 1. And it says to write this equation, 4x plus 2 is equal 5, in 3 different ways. And then we're going to use our calculator to check. Remember, our calculator tool that we are going to use is the nsolve. This is what we used in the last video. Remember, this technique is just a way to check. This is never a crutch. This is not how we solve equations ever. We don't just tell our calculator to do all the work and sit back and relax. So let's begin. So the first thing that I'm going to do is use the sorting method. And you might choose to look at this differently, but I'm going to leave the 4x on the variable side, the 5 on the constant side, and that plus 2, I'm going to use its additive inverse and move it to the other side. So what we should do right now is use our calculator to check. So let's first type in 4x plus 2 equals 5 in the nsolve. I'll give you a minute to do that and see what you end up with as your answer. So the first equation, you should end up getting x is equal to 3/4, or your calculator might have spit out 0.75, which we both know are equivalent. So next, in our calculator, let's use the same nsolve, and we are going to use this equation, 4x is equal to 5 minus 2. And voila, we get the same answer. We get x is equal to 0.75. So I'm going to simplify this yet again. 4x is equal to 5 minus 2, which is 3. So let's go ahead and use our nsolve to determine, did we do this correct? And as you can see in your calculator, it tells you that x is actually equal to 0.75 or 3/4. Same difference. We're getting the same output. Therefore, we know that we're not making any mistakes with our equation. So our last and final step, I'm going to divide both sides by 4. And I end up getting x is equal to, and I'm just going to leave it as a fraction, 3 divided by 4. Since 4 doesn't go in evenly to 3, I'm going to leave that. And of course, we can use an nsolve for this one, but really it's pointless because it's telling us what x is anyways. Your calculator is just going to tell you that x is 3/4 because that's what it is. So nice work. So as you can see, we've written it in 1, 2, 3 different ways. Now moving on to exercise number 2. In the left-hand column, you can see what it looks like with a normal variable. And in the right-hand column, we are going to see what it, and when I say it, we're talking about an equation, looks like as a formula, as a bunch of different letters and not very many numbers. So one thing to keep in mind is that we can use any method of solving equations. Some methods are maybe better than others. So some of you might say, oh yeah, this one looks like a great problem to do the sorting method, and sometimes it might look like a better method to use the balancing. And it really doesn't matter, just as long as you're doing it correctly. And it really doesn't matter to me either. So if some of you are like, oh, that sorting method is just not working for me, then don't use it, okay? Even though I might show it in the video, you want to just get the practice of writing that down. But if for some reason, you just are flat out against one method versus another, make sure that your answers match up with mine as we're working through the video. So as we look at number 1, it says to solve for x, and it says that to do that for 1, 3, 5, and questions 1, 3, 5, and 7. So you might look at this and be like, oh, Mrs. Ruscio, this is simple. This is just, I move the 4, then the negative 4 needs to be brought over to the other side. So let's add 4 to both sides of the equation, and we end up getting x is equal to 14. Okay, now I don't care that x is equal to 14, and I guess I shouldn't say I don't care. That's not the important part of this problem. The important part that we need to help us with question number 2 is how we moved that minus 4. I added 4 to both sides because a negative 4 plus 4 is 0. So let's take a look now at number 2. So number 2 says solve for a. So some of you might like to just highlight the variable that we're dealing with. In this case, we want to get a alone. So that means move everything that is not an a to the other side of the equal sign. I'm going to say that again. So everything that is not a, we are going to move to the other side of the equal sign. And we are going to do that by using our strategies, by either using the inverse operations or using the sorting method. But because in example 1, I added 4 to both sides, instead of subtracting 4, or rather adding 4 to both sides, I'm actually going to do something with this minus b. So how do I get rid of a minus b? Well, a lot of you probably are thinking this in your head right now, and you are right. We are going to add b to both sides. So negative b plus b, what is that? That's nothing. That's 0. So I am just left with a on the left-hand side, equaling. Now over here, 14 is really 10 plus 4. Well, can I combine a c and a b together? Are they like terms? Are they the same variable? No. So I actually can just leave my answer as a is equal to c plus b, and that's it. Okay, so let's move on to number 3. In number 3, if I wanted to solve for x, I would divide both sides by 2 to get that x alone. So x is equal to 5. So if I want to get, in question number 4, r alone, let's highlight r. So I want to get r alone. It's being multiplied by I. So how do I cancel out multiplying by I? Well, how did I cancel out multiplying by 2? I divided by 2. So I am going to divide both sides not by 2, but by I. And I divided by I is 1. So the i's on the left-hand side are no more. I'm left with r on the left-hand side is equal to, and since v and I are not like terms, I can't divide like I did in example 3. 10 divided by 2 is 5. I can't do that with v divided by I. So I'm just going to leave it. V divided by I. And there's your final answer. Okay, moving on to number 5. Well, x is being divided by 3. I need to solve for it to cancel out dividing by 3. What's the opposite of division? Multiplication, you're right. So we're going to multiply both sides by 3, and I end up getting x, because 3 divided by 3 is 1, is equal to 12 times 3, which is, I know all of you don't need a calculator for this, x is equal to 36. Nice work. Okay, so let's go ahead and do the same thing in question number 6. So we're solving for a. Our a is just like our x. So let's get a alone. Well, a is being divided by L, so let's cancel out that division with multiplying by L on both sides of the equation. L divided by L is 1. So I am now left with a equaling, well, can't do much with the left-hand side, so LW. Some people like to leave the multiplication dot in there. It really doesn't matter. You could have left it either way. Okay, moving on to number 7. Now, as you can see, there's a few more steps that are involved in this one. We need to solve for x, but I first need to get the constant, the plus 15, moved to the other side. So, let's get a little bit of practice using our sorting method. So the 5x would stay, the 20 would stay, but the plus 15 has to move to the other side because it's not a variable term, and instead of plus 15, it will be minus 15. So next step, we would actually group these together. On the right-hand side, 20 minus 15 is just 5. What do you think we do next? I got to get x alone. Divide both sides by 5. You are right. And 5 divided by 5 is 1. So my final answer is x is equal to 1. Now let's see how this looks in question number 8. Okay, we're going to use question 7 as reference. Instead of solving, well, actually we're solving for x here too. So I'm going to highlight x using my highlighter. Hopefully you have one too. And let's do the same thing. Well, I had to get rid of that constant, that number that was being added or subtracted at the end. In this case, it's not a number, it's a variable, but we're going to treat it like we treated the constant. So ax, that has my x term, and anything that doesn't have an x, we're going to move to the other side. Well, my r doesn't have an x attached to it, so my r stays. And my plus c has to move to the other side, so you got it. It's going to become minus c. Now this is where things are a little different because on the on the left-hand side, we could subtract 20 minus 15. Here, no can do. They're not like terms. So you know what? We just leave it. So our answers might look a little messier, but really, it's cutting out a whole extra step. I don't have to subtract c from r. But what I do need to do is get rid of that a being multiplied to x, so I divide both sides, the entire right side, by a. So my final answer is going to be x is equal to r minus c all divided by a. And some of you are like, whoa, we can leave it like that? Sure can. So we're going to do it. And in fact, it would be a lot trickier to do anything else at this point. So let it be and let's leave it. Okay. Nice work. We're almost done with these questions. So let's move on to number 9. Number 9, we need to solve for r. This one looks a little trickier because there's the squared in there. Some of you might be thinking back and racking your brains. Where have I seen this squared before? And some of you might say, oh, Pythagorean theorem. Yes, you're right. We probably are going to do a lot of the same strategies like you would when you were solving Pythagorean theorem questions. So the first thing I need to do is I need to remove, or I need to make that 5 move to the other side. And it's being multiplied, so we are going to divide both sides by 5. So I end up getting 4 is equal to r squared. And a lot of times people get to this point and they're like, oh, I'm going to divide both sides by 2. Well, nice try, but we can't do that because dividing by 2 is not going to cancel out squaring. So what is the opposite of squaring? Think, 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 think. If you are thinking, take the square root of both sides, you are a winner. So we end up getting r is equal to, well, what number times itself is 4? That's 2, but some of you might want to type this in your calculators, and that's okay too. So r ends up equaling 2 because the squaring and the square root cancel one another out. So use this to help with question number 10. We're solving for r again. Okay, so we need to first remove the number or variable, in this case it's the number pi, out in front, and we do that by using its opposite. It's being multiplied right now, so we are going to divide both sides. And remember, I cannot divide pi into a, so I just leave it. So a divided by pi is equal to r squared. And how do I get r alone? Well, look to the left, and how do you cancel out squaring? Well, you take the square root of both sides. So r ends up equaling, and some of you are like, oh no, what do we do? Well, you know what? We don't really do much of anything. We just leave it as a square root of a divided by pi, and that's it. All right, so now we're going to get into a few more advanced questions, just because we don't have the simple solving equations method right next to it. So we're going to have to come up with these strategies on our own. And in 11, we need to solve for k. So anything that's not a k, we need to move to the other side of the equation. Well, I'm going to first try to get rid of d, because d is being multiplied to k minus 7. I could also distribute. I'm just choosing not to do that here. But if you want to, that would actually be okay. Let's not do that though, because it will look a little bit different and I don't want to lose you. So let's divide both sides by d, because d divided by d is 1. So p divided by d is really equal to k minus 7. And I need to get k alone, so what can I do with that minus 7? Well, let's add it to both sides. And some of you might think, well, how on earth can I possibly add 7 to the p plus d? Well, the thing is, you can't really make it look, you can't group it together, so you're going to just leave it. P divided by d, all plus 7, is equal to k. And that's it. There's our final answer. Now moving on to 12, it looks like we need to find B2 in terms of A, H, and B1. So let's highlight B2. This is what we need to solve for and move everything else over to the other side. So I'm looking at both sides and I see that it's, it's really complicated on the right-hand side and not so complicated on the left, which makes sense. We have to move everything from the right side to the left side of this equation. So let's look at that 1/2. How can I get rid of a 1/2? Well, I could divide both sides by 1/2, or I could multiply by its reciprocal. I'm going to choose to multiply by its reciprocal, 2/1. Okay, so if I multiply both sides by 2/1, well, 2/1 is just 2. I'm actually left with 2a is equal to, well, 2 divided by 2 and 1 divided by 1 cancel out to become 1h, all times b1 plus b2. Notice how I didn't get rid of the parentheses. All right, let's move on. Now I could go ahead and distribute the h, and because I didn't do it in the previous one, let's go ahead and distribute, just so you can see another strategy. So 2a is equal to h b1 plus h b2. I had to distribute the h to both terms. So I need to get my b2 alone. So any term that doesn't have a b2, which is right here, this whole term needs to be moved to the other side. So I could even use a sorting method in this case and say that 2a doesn't have the b2, so it's going to stay on that side. And instead of a positive hb1, it's going to be a minus hb1 because I'm moving it to the other side of the equation. And that all will equal hb2, and we're almost there. So how do I get b2 by itself? Well, I got to get rid of multiplying by h, so let's divide everything by h. Every single term by h. That looks like a none. Okay, so you know what? I'm running out of space. Let's just move it up here as our final answer. So 2a divided by h, well, I can't group anything together, so it just stays. Easy breezy. Now, my next term, I actually see an h divided by an h. Those two cancel out. They become 1. h divided by h is 1. Minus 1b, 1. and that will all equal, well, here we see that h divided by h canceling out, becoming 1 again. That all equals b sub 2. So here we have our final answer in terms of B2. Okay, so I want to challenge you. I want you to try doing this on your own. So pause the video right now, and then I'm going to talk through my solve at the end. Okay, so here's our final answer, and let's talk this through. So I first multiplied both sides by 3/4 to eliminate my 4/3. So that's what I got here in blue. 3/4 v is equal to pi r squared h. I divided both sides by pi times h because the r squared was being multiplied by pi and h. So I divided both sides by pi h. Then I'm left with 3/4 v all divided by pi h is equal to r squared, what I have in the blue. To get r alone, I took the square root, I used the inverse of squaring, and ended up with my final answer here. Now, if you didn't get this or didn't follow along, this would be a really nice question to circle and just write a note on and say, you know, hey, Mrs. Ruscio, I need help in class. Please help me with this while we're doing our independent work time. Now, down below, you can see that we can actually check for the most part using our store key. I'm not going to go through this with you in the video because I'd like to actually do this with you in class using our actual calculators instead of the ones on your iPad. And I think it's a little bit easier to do when you don't have to multitask, watch the video, then swap back to the iPad app. So we'll postpone this and make sure that you ask lots of questions if you weren't sure about something that was in this video. Nice work.